All right, welcome back. This is the second video in the robotics training curriculum in your basic required information section. And what this video is going to cover is just an introduction to the different subsystems on a standard FTC robotics team. So as you can imagine, a robotics team, even with just 15 people, has many different purposes and functions and things that it needs to do. And really the most effective way to get all these different things done is to have different subsystems of people. So you have different groups of people who are all focused on different things that they are able to execute. And then when you come back together as a team, you have multiple different tasks that are happening. You're really able to get everything done that you want to. And so the subsystems we're going to cover, we're going to quickly go over what robotics is again, and then cover CAD design, hardware, software, and business management. So this is a slide you guys have seen before. Just to go over, robotics is an interdisciplinary field of engineering and computer science, and its purpose is to design and create intelligent machines that can more efficiently and with less risk replicate human actions. And so what that means to us in FTC is the robots that we are going to be building are going to be able to execute tasks that we could do as human beings, but it may be more efficient or just easier to do with a robot. And there will be many things that you'll have to do to build this robot. As I talked about in the last presentation, there's mechanical engineering, electrical engineering, computer engineering, and computer science. And that doesn't even cover everything that will be on your FTC team. But just from those four fields alone, you can tell that there'll be a lot of different things you really need to keep in mind here. So going first into CAD and design. So CAD stands for Computer Aided Design. And essentially what CAD is it's the utilization of a software to design a part on your computer or your laptop, and then you can use that design file to either custom machine the part or just to have a visual model of it. And the real advantage to using CAD, this is the section that is the least necessary. In fact, a lot of teams don't actually CAD, which is completely fine. But some teams will CAD because they want to be able to build custom parts that fit the needs of their robot. If they have a certain joint that they need that needs to be really small, but they don't have a standard kit part for it, then CADing the part and then custom manufacturing it allows you to create what you need so you can solve the problems that you have the most efficiently and the best way possible for your scenario. Another really great thing about CAD is you can plan out your entire robot before you build a single thing. So some teams, not a lot of them, will actually CAD their entire robot before they build anything. So they have the entire thing modeled out, they know exactly what parts need to go where, and that allows them to build things much quicker, and also there's a much higher probability that when they build the robot, everything will work as planned because they've already seen it work in the visual model. Now, CAD obviously requires a software, and so there are three main softwares that I'm just going to quickly highlight here. They're called SolidWorks, Fusion 360, and Autodesk Inventor. So Fusion 360 is actually also designed by the company Autodesk, but it's considered a separate software. So starting from the top, SolidWorks is the most complex software. It's generally used in a lot of corporate environments. It's also actually quite expensive, so I would recommend looking into your team's finances before investing in SolidWorks, but it's a really great software for planning out really complex models, just getting familiar with the software you'll probably have to use in college in the industry, and also offers a lot of features that could be really useful to your team. Now you have Fusion 360. So Fusion 360 is a really, really great software. So it's actually the only software on this list that's compatible with both a Mac OS system and a Windows PC system, which makes it really, really great for most people because then you aren't limited by your computer hardware. It's also a completely free software, so you can download it off the Autodesk website and has integrated CAM into it. Now CAM might not mean anything to you. It'll be covered in a much later video about machining. But what CAM allows you to do is to render a part to actually custom manufacture out of metal. And so for some teams, that's a really, really useful attribute of a software. Fusion 360 also has cloud-based storing. So while SolidWorks, you save the file locally to your laptop, Fusion 360 saves it to your account in the cloud. And so if you're going to switch laptops or you're going somewhere else and you're going to be using a different computer, you can log into your Fusion 360 account, you'll have all your part files right there. And so this is actually the software that when I get to And so this is actually the software that when you go to the CAD tab on this website and you check out some of the resources there, this will be the software that I'll be teaching CAD in, just because it's free, it's really great for multiple systems, cloud-based storing, and it pretty much has everything that you'll ever need to CAD, especially at the level that we'll be at for robotics. So highly, highly recommend Fusion 360. And then you have Autodesk Inventor. So Autodesk Inventor was sort of the big free software that preceded Fusion 360. It's still super powerful software. It's only compatible on PC, so if you're running a Mac, obviously it's not going to work out too well. But also highly recommend Autodesk Inventor because if you get it with a student account, it is also free. Now going back to the general idea of CAD and design, it's most related to something like mechanical engineering or a design if you're sort of looking into future careers or college majors or whatnot. And it requires some level of hardware and design knowledge. So generally people who are CADing have some experience just doing hardware, just building things, because you kind of need to have that idea of how everything pieces together, how you want to build things in that visual software. But you don't need a ton of experience. You really can learn so much on the job with CAD. You also need to know how to collaborate. Most of the time, there's more than one person who's CADing, just because it does become a lot of very tedious work. And then flexibility for if things don't work out, if you really need to iterate, just test things over and over. And then creativity, because obviously this is design. It's a little bit more artistic in a way than a lot of the other areas of robotics. And so a lot of people who are really into art and that kind of thing actually become really, really good at CAD design just because they have that ability to visualize things and design things. Now hardware is generally the biggest subsystem of any robotics team just because it is building the robot hardware, as I'm sure you can guess. It's physically building things, it's implementing the designs that might have been designed by the CAD team, or that might just be coming out of kit parts, machining, manufacturing, etc. Obviously, this feels a lot more like mechanical engineering, but some teams who don't have a separate electrical subsystem might also include electrical engineering in this hardware section. Specifically for FTC, there isn't usually a ton of electrical engineering work that needs to happen, so most of the time this will be part of hardware. And it requires that same creativity and design as CAD would, more so if there is no CAD team. If there is a CAD team, the robot's fully CADed, you can pretty much copy it, but most of the time you do need to have that same ability to visualize and design things. Same idea with adaptability. There'll be a lot of iteration, a lot of designing things and then redesigning things. And so just really keep that in mind when you're going in, that the first time you build something is probably not the last time. Now we go into software. So software is most related to computer science. It's programming your hardware systems to do the actions that you need it to do. And so that's utilizing a lot of the motors, the servos, the control systems that you have on your robot to tell the robot what to do. And the really great thing about software is you don't need a ton of software experience to do software, because you can run a perfectly fine functioning robot on very little software, but you can also make it super duper complex and full of different types of functions and all these things. So really, your software programming and your code will grow with you as you continue to learn. And so that's a really, really nice thing about software. It requires some level of programming experience. Obviously, you need to be able to write your actual code. You need to be able to figure out the logic puzzles. There'll be a lot of if-then statements and whatnot that you're dealing with. And then perseverance, because I will say, software is the team that probably spends the longest stretches of time in your robotics room, working on things, trying to test things over and over and over again. So it really just requires that mental and physical perseverance. But software is super fun, so don't worry too much about that. And the last section, which actually in my opinion is the most important section of a robotics team, is your management team. So not only do I think this is the most important, but it's also the most diverse in a way. It contains a lot of different tasks and roles and jobs that you can have. So management actually includes things like business, finance, some amount of writing and technical writing. It includes a lot of talking to people, a lot of project management a lot of the time, some social media interaction, all those kinds of things. And because of this variety and diversity of the field, management is often taken on by people who are in a different subsystem. So for me personally, I am part of hardware. I do a little bit of CAD design, but then I'm also involved in management just because having the skill set of being in hardware and design allows me to lead my team, be in that kind of managerial role a lot more effectively than if I was just focused on management. However, the people who are usually in charge of management are solely focused on this because it is a lot of work. Managing all these different types of things, I mean, as you can imagine, there's so many things you need to manage. So it does require a lot of dedication, a lot of work, but it's super duper crucial to your team because without a functioning management system somewhere, your team just can't function. It's most related to what you consider to be business or business administration, or maybe even finance, but it really just encompasses so many different things. So some of these words might seem a little weird, like outreach, notebook. We'll get into those in different presentations. Just know that management is this really big, encompassing thing that has a ton of different opportunities for whatever you're interested in. And it requires the ability to communicate, manage your time, be responsible, have a little bit more organization. Because obviously, if you're project managing a robotics team, you do need a lot more of these sort of responsibility management skills that other subsystems may or may not have. Okay, now going into subsystems, I've kind of touched on this with my own personal experience, but you're not confined to one subsystem. The really great thing about FTC with the small team environment is that you can really just sample and try out as many things as you want to within the course of a season or in consecutive seasons, just based on what you think would be interesting, maybe a skill set or something that you haven't tried before. Maybe you're just curious and you say, I've tried everything except for this one field. Let me just go do that now. And being part of these subsystems, I've talked a little bit about how maybe CAD and hardware are more mechanical engineering, software is computer science, management's more business. But that doesn't mean that by joining these subsystems, that's what you're going to do for the rest of your life. Because obviously, high school, it's 4 years. It's not going to determine anything in your future. And it really just gives you that experience, that diversity of experience that will just be really, really helpful for you going into the future, having an idea of what you like to do, maybe what you don't like to do, what you're good at, what you're maybe not as good at, you need to improve on. So just really great to sample different things, get that experience. And I gave some definitions, I gave some skill set examples and whatnot, but that's completely confined to my own personal experience. You might find that I was completely wrong. There are all these different things that you need, but this is just based on what I've seen in the last 3 years, what I've observed from other people, what I've observed for myself. And if you don't have maybe the skills required that I mentioned, that doesn't mean that you can't do whatever the role is that you are interested in. Because skills are things that are learned and that are acquired, not things that you're just innately born with. And so maybe you want to go into CAD design, but you don't have that hardware experience. That doesn't mean you can't do CAD design. That just means that that's something you should keep in mind, is that I need to learn how to do this hardware thing because that might be a skill that I'm a little bit more lacking in. But sort of just as a word of advice, I would say that if you're interested in a certain subsystem and you don't feel like you're qualified, still say that you're going to do that subsystem and just learn how to do it. Because if you're interested in something, you're just going to be so much better at doing that no matter what your experience level is. And so that's the end of this presentation on robotic subsystems. There'll be another assignment up on the website for you to take a look at. But I hope that this was helpful in understanding the different subsystems on a robotics team, understanding maybe what you would want to do in future seasons. And I'll see you in the next video.